In this example, we have 4 pH measurements made in each of 2 rivers, A and B. This gives us 2 data samples whose values are independent of each other. We can test for a difference in the variance between the 2 data sets and for a difference in the mean values by using the same analysis, that is in Analyze, Compare Means, Independent Samples, t-test. Within this test we have to identify the test variable, which is the value of pH, and the variable which identifies the 2 samples, which is the grouping variable. We must define the names of the 2 groups by clicking Define Groups. And for group 1 we have river A, and for group 2 we enter river B. Continue. And then we can just run OK. In the results for the analysis, we see Levene's test for the equality of variances between the 2 samples, giving us a p-value of 0.606, which suggests that there is no significant difference in the variances of the 2 samples. And then it performs the t-test. The analysis calculates the t-value, and then if we continue with the t-test assuming equal variance, we use degrees of freedom, which is equal to 4 plus 4, the sum of the 2 sample sizes minus 2, giving degrees of freedom 6, and a significance value of p equal to 0.052. i.e. we're unable to identify a significant difference between the 2 rivers. If the variances were not equal, we would have to use the results of equal variances not assumed. This is Welch's test, which uses a modified degrees of freedom and calculates a p-value of 0.054. If we wish to do a non-parametric test for a difference in the median values, we would use Analyze, Nonparametric Tests, Independent Samples. We would customize our analysis, selecting fields where we are testing the pH for the 2 different groups defined by the rivers. We can identify particular tests, and so for independent samples test we would use the Mann-Whitney test and run. This gives a p-value of 0.057, which again, because it is greater than 0.05, means that there is not sufficient evidence for a difference between the median values of the 2 rivers, and we retain the null hypothesis that the true median values are the same. For further information, we can double-click on this test summary, and this gives us further information about the analysis, including the calculation of the Mann-Whitney U value, and again showing us that the calculated p-value is 0.057.